what are the last two operations? I haven't talked about yet. What? Addition and subtraction. So we're going to be adding and subtracting our rationals, nouns, then. Now we do need to remind ourselves, like if we had something like 2/3 plus 1/6, how are we able to add those two fractions? Yeah, we gotta find a common denominator. Is there a specific kind of common denominator? The least common denominator. So notice that like 3 and 6, I could use 12 as my common denominator, okay? But is there something smaller than that they will both go into?
6.
6. So we want to use our least common denominator. That way we don't have to simplify at the end. It's not the end of the world if we have to simplify at the end. It just saves us a step if we use the least common denominator. Now, if I'm looking at 6, what are our factors of 6? 2 and 3. Yes? So what factors does 3 and 6 share? 3. Okay? Now, what factor is 3 missing? 2. So that means that I have to multiply the top and the bottom of my first fraction by what is missing, which in this case is 2. So then, what do I get for that first fraction? 4/6, and then here I still have 1/6. So then if I simplify that, what do I get? 5/6. Why is it 5/6 and not 5/12? It is not a super valid answer. So I agree, yes, we just add our numerators and not the denominators, but yeah, so like if I have a 4/6 of a cookie and I add 1/6 of a cookie, yes, I have 5/6 of a cookie. So I almost have a whole cookie. Agreed? Versus if I change that to 5/12, you have less than half of a cookie. Does that make sense? So we're talking about adding parts of a whole together, yes, which means that your parts are still broken up into the same number of pieces, which in this case is 6. And we have 5 of them. Okay? Now, if we add in variable, okay, our process is still going to be quite similar. The only difference now is that when we look at our factors, we have x's in it, okay? Which means that we might have things that we have to factor ourselves in order to find our factors. Yes? So in this case, which one of our things factors? The denominator of the second fraction. What is it going to factor to? Agreed. Because it is a difference of squares, which recalls from our formula sheets that we got. Yes? So now, do our denominators have any common factors? Is x a factor of my second denominator? Meaning it's being multiplied? No. Now I have an x minus 1 and an x plus 1. Those are its factors, but x by itself is not a factor. Which means, what is my first one missing? Or what do we have to multiply it by? Not our first one. It already has an x. Not a -1. -1 is not a factor. X minus 1 and yeah, so we need to multiply that first one by an x minus 1 and an x plus 1 to the top and the bottom because that's what's going to be missing from the common denominator. Now, what do we need to multiply the second one by? Or what is it missing?
X.
Just an x. Are we all okay with how I got those? It'd be the same thing like if we had 2/3 and 1/2, right? My 2 and my 3 do not share anything, so I just multiply each one by the other. Yes. So here, my x and my x minus 1, x plus 1 don't share anything, so I just have to multiply each of them by the other denominator. Now, notice, do I have the same denominators on both of those now? Yeah, right, I have an x minus 1, x plus 1 on both of them, and I have an x on both of them. Yes? So what are we allowed to do? I can't reduce them yet. We can add them. So we would have 2 times x minus 1, x plus 1, plus x times x plus 3, all over our common denominator, which is x times x minus 1 times x plus 1. Now be careful, because this is the step that people tend to make mistakes at. Okay? What do I have in my numerator in between my two things? An addition sign, yes? So is the numerator in factored form? I just have multiplication in between each thing. No. Okay? Which means that we cannot reduce anything either. Okay, so a common mistake is that people want to start. Alright. So, we cannot start just reducing the x minus 1s and the x plus 1s here, or the x's, because those are not factors of our numerator. Yes? Are we okay with that? But I think some of us get caught up in our steps, and we want to reduce things, so we just start crossing stuff out. Alright? Now, we do want to simplify the top, so notice that our bottom is already in factored form, so we don't need to multiply that out. However, on top, it is not in factored form, and it is not simplified, so we need to simplify that. So, if I multiply the x minus 1 times x plus 1 out, what are we going to get? What should we get? X squared minus 1, right? Notice that we factored x squared minus 1 out to get x minus 1, x plus 1. So if we multiply it out, we should get back to the x squared minus 1. Yes? Okay. So now we have 2 times x squared minus 1. And then if I distribute that x, what do we get there? X squared plus 3x. Okay. So then what do we want to do? Can we simplify that any further? Yeah. Distribute the 2. And then lastly, we need to combine any like terms. So remember, we have to have the same exponent to have like terms. So in this case, we have a 2x squared and an x squared, so we end up with a 3x squared plus 3x minus 2. And again, our denominator has stayed the same. Now, we do want to check and make sure that our numerator doesn't factor. Okay? Remember, we would do...
Nathan Benton.
Yes?
Could I have him to the office just at your earliest convenience?
Okay, thank you. Alright, we would do our AC method. So notice that we have 3 times negative 2, which would give us negative 6. So we would be looking at what multiplies together to give us a negative 6. that adds together to give us a 3. Well, remember our factors are 1 and 6, or 2 and 3. So none of those combinations are going to give us a 3, so it's not going to factor. So that's as simplified as that numerator is going to get. So that would be my final answer. Yes. Now, yes, these questions have a few more steps than some of our other ones, but no, remember, just because we have more steps doesn't necessarily make the problem hard. It just takes up more space on a piece of paper. That's it. Okay? Because none of those steps were necessarily hard, like in and of themselves. So you just kind of had to figure out what's the next part that we need to do. Agreed? Yes?
Yes.
So, let's have you try one on your own. This time we have subtraction. However, it's going to work the same way. Okay? Just whenever I combine my numerators, I'm going to subtract them this time. Alright, so then remember, once I have the same denominator, we can just subtract our two numerators. And then we're going to just simplify that numerator. Our goal is to put things in factored form if possible. So our denominator is already in factored form, so I probably wouldn't multiply it out. It's not wrong if you multiply it out. So I distributed the x, distributed the -2. You could also just distribute a +2, but leave the subtraction sign there. That's fine. And then we have 3x squared plus 2x plus 6. And again, we want to check and see if that numerator factors. Okay, so we would do a times c, which gives us 18. Is there anything that multiplies together to give us 18 that adds together to give us a 2? Yeah, like one of them would have to be negative in order to go from like something bigger, right, to something smaller like that. But because they're both positive, there's not going to be anything. So that would be our answer. Questions on that? Again, remember, because this is subtraction, we cannot reduce factors. Yes. The only time that we could potentially reduce factors is like if this here at the end did factor and they both had an x minus 3 in them, now I could reduce them because they're both in factored form. Yes. But until I get to basically this very last step, it's not in factored form. Like I have subtraction, we have subtraction, we have more subtraction, or you're going to have addition. I cannot reduce things when I have subtraction or addition. Yes? I know it seems like I'm repeating that, but that is a very common mistake that people just want to start crossing stuff out a lot. Okay? So let's look at one more example together. Alright, again, what are we looking for in order to be able to add things? Common denominator, yes. So in order to find our common denominator, we need to factor, okay? So which one of those is going to factor? The second denominator. Again, we can look at our C value and our B value. So we're looking at what multiplies together to give us a -2, that adds together to give us a -1. What do we think? A -2 and a +1 is what I heard. Yes? So this time, do we have any common factors? Yeah, we have an x plus 1 in common, okay? Which means that I do not need to multiply either one of these by an x plus 1. Kind of like that first example that we looked at with the numbers. They both already had a 3. I don't have to multiply by a 3, okay? What's the only thing that my first one is missing, though? X minus 2. So I just have to multiply that first fraction by an x minus 2. The second one already has an x minus 2 and an x plus 1, so we don't have to multiply it by anything. us this stuff. And then we can add our numerators. Can I reduce those x minus 2's?
No.
Why not?
They're additional.
So x minus 2 is a factor on bottom, but right now it is not a factor on top because we have that extra x plus 2. But we can distribute that x. And then again, we want to look at, is there anything that is going to multiply together to give us a positive 2 that adds together to give us a negative 2? Your factors of 2 are 1 and 2, right? So either they both have to be positive in order to end up with a positive, so that would be 1 and 2, and then you would get 3 in the middle, or they both have to be negative, so it's a negative 1 and a negative 2, so you'd end up with a negative 3 in the middle, so that also does not factor. Yes? Maybe? Questions?
What if I say no?
We're all okay with figuring out what our common denominator is, multiplying by what we need to multiply by, and then reducing when we